Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. Hope you are well. Our today's lecture is about Wheatstone Bridge. Wheatstone Bridge is an instrument which is used to find the uh, unknown resistance. But before discussing the Wheatstone Bridge, I have to discuss few points about the selection of loop and about the selection of mesh point when these mesh points are when these mesh points are uh, used for the application. Loops and mesh points are used for the application of Kirchhoff's law, because in the last lecture we talked about the two laws which are called Kirchhoff's laws. One of them was current rule and other was voltage rule. In order to apply the current rule or voltage rule, we have to select the circuit, and also we have to select the loops in the circuit. So first point is to draw the circuit diagram and then choice of loops. And during choice of loop, it should be such that uh, each resistance is included at least once in the selected loops. What does this mean? This means that the loops should be selected in such a way that at least uh, once each resistance can be included in either of the loop, in first loop or second loop or third loop. This does not confuse with the concept that each resistance should be in each loop. This is not the concept. Each resistance should be included at least once in the selected loop, at least once. By writing at least once, this means that a resistance can be included in a in selected loop in one or two loops or two times in two loops. Same resistance in maybe in the two loops. We will see the example shortly. Assume the loop current in each loop. In each loop, all the loops current should be in the same sense. What does this mean? This means that if there are more than one loop in a circuit and you consider the current in one loop in anti-clockwise direction, then all the currents in all the loops should be anti-clockwise. It is not our duty to select the correct direction of the currents in the loop. We just uh, assume the direction of current in the loop. But you should keep in mind that if there are more than two loops or more than one loop, for example, two, three, or four loops, then if in one loop we assume the current in anti-clockwise direction, then currents in all the loops should be anti-clockwise. This is the point. Next, write the equation for each loop. The equation means write the sum of voltages uh, in each loop, traversing each loop should be equal to 0. And after writing all the equations for all the loops in the circuit, we should solve these equations simultaneously for the unknown quantities. Let us apply this concept to the to our topic, which is named as Wheatstone Bridge. Wheatstone Bridge. Our today's topic is Wheatstone, and it is important long question. You should keep in mind that it is an important long question. Wheatstone Bridge. Let me explain what is Wheatstone Bridge. Wheatstone Bridge is actually a combination of four resistors. Four resistors. How these four resistors are included? I am going to make this combination of circuit before you. There are four resistances which are arranged on a as the sides of a square, and also name these equation as R1, R2, R3, R4. When these resistors are arranged in this way, there are four vertices. There are four vertices because they are arranged as the side of a square. So keep in mind that we apply or we connect a galvanometer between two vertices, opposite vertices, and we apply a battery with a switch between remaining two vertices. Please keep in mind that this is the simple way to arrange to find the to draw the Wheatstone bridge circuit. So it consists of four resistors which are arranged as shown in figure, is called the four resistances or resistors arranged as shown in the figure is called Wheatstone bridge. This is the simplest possible definition of Wheatstone bridge. As I have told you, the use of Wheatstone bridge is to find the value of unknown resistance. What does this mean? This means that this circuit will be used to find the value of unknown resistance. Okay, let me show you how we can find the formula for unknown resistance. This is important long question, so you should keep in mind that though long question, this is important long question. Now we apply the rules as we discussed in the first part of our lecture. Here is a circuit which seems to be a complex circuit, and in this circuit we have three loops. Let me name these loops A, D, B, A. One loop is A, D, B, A. Second loop is C, D, B, C. You can start loop from anywhere else, either in uh, designating its the loop name or in deciding the loop sequence of the sequence as a loop. Next third loop is A, starts from here and goes through the switch to the battery and goes to the C point and then D point and then again A point. So what is this loop? This loop is A to C, C to D, D to back A. So this is the third loop. Now we assume the select the loops. First step is select the loops in your circuit. Next step is assume the current direction in loops. Okay. Now, as I told you, we can select the direction, any direction of a current, of current in a loop, that is either clockwise or anti-clockwise. But remember that we have learned that if we will assume the direction of current in one loop clockwise, then all the loops should have clockwise current. For the present case, the current in left loop is anti-clockwise and also the current on remaining two loops is also anti-clockwise. After assuming the current direction, the third step is to apply the Kirchhoff voltage rule, because Kirchhoff voltage or loop rule is applied to the voltage. Let us consider the loop A, D. Keep in mind that we should name the loop in the direction of current. So it would be easy to apply to write the voltage equation or loop equation or Kirchhoff's second rule for this loop in without confusion. So for the present case, I am starting that my current in the loop A, D, B, A is I1 and in the anti-clockwise direction. Now we start from the point A and go to the point B and then go to the point D and then go to the point D and then back to A. Uh, during traversing in the direction of current, always keep in mind that we always move from high potential to low potential, because current always flow from low potential to high potential to low potential, because we always assume conventional current. So from A to D, when we go from A to D, the resistance is R3. So R3 is the resistance and the potential difference is the current through the resistor multiplied by the value of the resistance. For the present case, you see that if this resistance R3 is included in two loops, one A D B A loop and one A C D or and A loop. So current due to loop A D B A is I1, while current due to loop 3 is equal to I3. But this time we are inside the loop A, D, B and A, where we assume that the current should be in the anti-clockwise direction. So in this region, in this resistance, the current I1 should be greater than current I3, so that the net current will flow in the anti-clockwise direction. This is the main point to understand. So what I should write here, I1 minus I3 into R3, and I also put a negative sign with this because uh, we are traversing a resistance in the direction of current, and whenever we are traversing the current in the direction of current, we always move from high potential to low potential, and when we move from high potential to low potential, the energy loses, and loss in energy is always taken negative. So I have put here the negative sign in front of I1 minus I3 into R3. Next is the galvanometer. Next, the current pass through the galvanometer, and also keep in mind that galvanometer is in both loops. It is included in the loop A D B A, and also it is included in the loop C B D C. So again we use the same argument as I have already told you. It is multiplied by resistance of the galvanometer. It is also taken negative because we move in the direction of flow of current, and then uh, we will move from B to A, and the resistance here R1, and current through this resistance is I1. R1 is equal to 0. This is loop equation for loop A D B A. Now we consider the loop C B D and back to C. Snow, we write the equation. When we move from equation from point C, we start from point C. We can start from anywhere else. We can start from point D. We can start from point D. If you want to start from point D, you should keep the name of loop accordingly. For example, if we want to start the loop from D, D to C, C to B, B to back D, you can name it as you want. But for the present case, when we move from D to C, energy will be lost and the current will be I2 minus I3 through the resistance R4 minus I2 R2 minus, now in the case of galvanometer, current would be I2 minus I1 net current into resistance of galvanometer. This is equation number 2. In the balancing in the balanced condition for Wheatstone Bridge, we have zero current through galvanometer. So next point, you should keep the next point in mind. Keep in mind that the Wheatstone bridge is balanced condition if the current through the galvanometer is zero. That is, when current through the galvanometer is zero, when I1 current is equal to I2. Putting I2 is equal to I1 in above equation. Where there is I2, we will put I1, and where there is I1, we keep as it is. So from equation 1, from 1 minus I1 minus I3 into I3 minus I1 is equal to I2. This would become 0. I1 minus I1 into RG minus in the last I1 R. I1 R1 is equal to 0. This term becomes 0. Similarly, in the second equation, what we put? Minus I1 minus I3 into R4 minus I1 R2 minus I1 minus I1 into RG is equal to 0. This also goes to 0. What we are left with? We are left with minus I1 minus I3 into R3 is equal to I1 R1. Similarly, minus I1 minus I3 into R4 is equal to I1 R2. This equation is 4. 3. This equation is 4. Now, 3 divided by 4 gives 3 divided by 4. What is 3? 3 is I1 R1. What is 4? I1 R2 is equal to, what is 3? Minus I1 minus I3 into R3 divided by minus I1 minus I3 into R4. This cancel out. This cancel out. What we are left with? We are left with R1 over R2 is equal to R3 over R4. So this is the Wheatstone bridge equation when Wheatstone is in balanced state. If R1 is unknown resistance, then R1 is equal to R3 over R4 multiplied by R2. If R1, R3, R4, R2 are known, then we can calculate R1. Sometimes it is R1 is written as X, that is unknown resistance. So how this circuit can be used? Actually, we draw this circuit, use the battery, use the galvanometer, and in place of any one resistance, we place unknown resistance like X, and these resistance are adjusted in such a way that the current through this galvanometer is zero. As a result, the resistance of this X or R1 can be calculated with the help of this relation. So this is all about Wheatstone bridge. This is important long question. Important long question.